it, sir?
Sure. Yep. So welcome to this session. So in the no, in the session number 2, we had discussed till what we can do, using Matlab for image processing applications. So we discussed about some basics, about the toolbox, and we also discussed about some basic, input and output operations. Post which we started with few set of image processing workflows, such as image enhancement technique, where we used the technique called as histogram equalization. Then we also talked about the thresholding concept, and we also saw how we can do thresholding using optimum algorithms which will be able to compute the optimum threshold value, or we were also able to see how we can do manual thresholding for our given custom threshold values as well. And post which we also discussed where this thresholding is applicable for applications such as edge detection, and we were also able to see how we use those, how we use the thresholding and how basically edge detection algorithms basically operate to detect those edges. We used multiple operators such as we used Sobel operator, we used Previtt operator. We also saw the usage of canny edge detection operator, and we were also sorry for that, yeah, we were also able to see using Matlab how we can easily achieve those results very quickly as well. And we also saw that all these functions which we are using are not like black box functions. So all those functions has complete documentation, so we are also able to see if we come across any new functions such, and if we are also able to come up in a situation where we are not able to understand why we are able to get those kind of results, so how we can make use of documentations to easily get the right kind of inputs from the documentation, with the help of which we can easily understand why we are basically able to get such kind of results in a very simple way. And if we want to even get modified results, how we can make use of input arguments, and we can tune those parameters so that we can easily get the right kind of results. So now let us continue our session. So now we will move a little bit further, where we will go to the preprocessing function, which is normally applied post these kind of functions are used, such as if we do edge detection, and once the end result of edge detection are available, there may still be some imperfections that are present in those results as well, right? We were able to see that in the previous result, where we were able to do the edge detection for coin, right? If we consider only the circular region of that edges to be detected, then Sobel or Previtt operator were pretty much able to give me good kind of result. But still there were some small imperfections, right? The embossings within those the cell, there were some minute edges being detected there. But I don't want that to happen. I want to clear out those. Even though you will do edge detection, rarely you may get 100% perfect result. Most of the cases you may even have some edges being detected which are not intended to get result. That means which you had not expected the edge detection algorithm to do the edge detection with. So that is pretty much common in image processing domain. So that is where the morphological operations will come into picture. So these particular morphological operations, so using we what we basically do here is, so we will identify which are the regions which are not necessary for us, and using simple technique we will try to remove those regions in a simple way. In some of the cases we may use in neighboring hood operations to do that. In some of the cases you may use some simple thresholding techniques. So we have in Matlab we have simplified workflow to do apply those pre-processing technique, which is morphological operations, to be applied. So basically for this particular application, it is not necessary that you have to use grayscale images itself right now. the morphological operations which are available in the MATLAB have been extended to even black and white images of JPG images, which are multi-channel images as well. Even for those images, these morphological operations are pretty much supported. But now, still we will, for our workflow purpose, we will limit ourselves to still grayscale images itself, and we will try to understand what this morphological operation is, how these kind of operations helps us to achieve those imperfections which were present in those previous operations can be easily rectified very quickly. So now the first kind of morphological operations, which you can come across. So let us easily understand that. So when it comes to morphological operations, so the first set of operations are called as fundamental morphological operations. Under that, we'll be discussing very quickly about two kinds of operations we can do. One is called as dilation, and one more morphological operation under fundamental operation is also known as erosion. So other than that, we also have something called as compound morphological operation. So where we combine dilation and erosion function in a sequence order, and by doing that we can come across with two other kind of operations which are basically the combination of these two fundamental operation. So which is basically called as opening morphological operation, and one more operation is also called as closing operation. So since we have now known what are these kind of what are the morphological operations we can do, let us understand these morphological operations in a bit quicker manner, and let us see what you mean by the what is the basic requirement for our morphological operation. So when it comes to morphological operation, we need something called as structuring element. We need to define a structuring element. So when it comes to defining the structuring element, we have flexibility. So what do you mean by this structuring element? We were discussing light. So basically morphological operation is a neighborhood based operation, similar to the image filtering whatever you do. So we will have a filter kernel which will be able to do neighborhood operations around a pixel of interest, and it will be able to compute the filtered result, right? Similarly, even we have similar to that kernel, in the morphological operation we have something similar to that called as structuring element. But even though it may look similar, but you have to keep it in mind that it is different than kernel. So let us understand how this structuring element, even though it may look similar, but it is still different than kernel. The number one difference is the values that are present in kernel and structuring element. In kernel, we can have real number values depending on the kind of filtering you are applying. So for example, if you are using a median filter, and if your kernel size is 3 cross 3, then normally your median means the element value will be 1 by 3 cross 3, right? 9. 1 by 9, which is approximately 1.1, sorry, 0.11 is the value that will be present in the kernel elements. But in structuring element, that is not the case. The element values that are present in the structuring element are binary values. It can be either 0 or 1. No any other values are supported. So that is first difference, we have to keep it in mind. And the second major difference is, for the kernel, the shape of the kernel is fixed. It will be a square shaped kernel, right? It can be 3 cross 3, it can be 5 cross 5, but the shape is pretty much fixed. It is a square shaped kernel. But when it comes to the structuring element, so as the name itself says, so the structure of that particular thing can be decided from our end. So if the the area or the region where we are doing morphological operation, if it is a smooth or a curvy edged based region, then we can define our structuring element to be circular shaped kernel, sorry, circular shaped structuring element. Or if the region is flat, or then we can focus on square or rectangle based structuring element. And if the regions are sharp, then we can focus on diamond based structuring element. We have different shapes. So these are few set of examples I have taken. There are various other shapes we can define. I'll be showing you in the documentation as well as we go through the implementation. there are various other shapes we can choose for our structuring element shapes. Whatever we are defining, there are multiple other shapes we can take, starting from simple point based structuring element till we can go to line, or we can we can choose multiple other shapes as well. So we have flexibility, but when it comes to filtering kernel, we don't have that flexibility. So that is something you have to keep it in mind. So that is where, even though the structuring element may look similar to the kernel, but even though it is totally different, the kind of operation it will do, it will be same neighborhood operation. It will go stride by stride to each uh, you know um, pixel, and it will do the neighborhood operation. But even though, compared to the shape and the element values that are present in those in that particular structuring element, so structuring element is totally different than a kernel. So now, coming on to the actual part. So now let us see few set of examples how the structuring element may look like. So we have three set of structuring elements that are available. On the very left end, we have a square shaped structuring element, where we have all the kernel values the element values in that structuring element to be 1, and the center value is the value which will be focusing on that main pixel. And along with that, we have one more structuring element which is having diamond shape, where the corner elements are valued evaluated to be 0, and we are keeping all the other elements to be fixed to 1. And similar to that, we have a circular structuring element for a 5 cross 5 element. So depending on your requirement, you can change the shape of your structuring element, so it is flexible for us. So now, keeping that in mind, so let us understand the image morphological operations very quickly. So the first basic operation we can do is basically called as image erosion. So what do you mean by image erosion is that, so whenever we want to reduce the total size of our resultant binary image, whatever it may be, then we may use this particular operation. Sorry, we have taken the example of dilation. Sorry, let me clarify that. We are doing the opposite operation. So dilation operation is basically enhancing or increasing the total size of the particular resultant binary image. So if you want to do that, if you want to enhance the size of your resultant binary image of any particular region of interest, then for those region we can easily apply dilation operation, and we'll be able to achieve that. For example, if you are able to see, after some thresholding and doing some edge detection, I'm able to get this particular binary image, so where we have the letter A being detected. And if I want to enhance the size of this edges, right, so I can easily apply a dilation operation, and you will be able to see, for the square structuring element with the size 3 cross 3, we have the resultant like this, where the edges are little bit more thick, right? And if I want to increase the dilation operation much more, then just increase the dimension of the structuring element. For example, if I, instead of 3 cross 3, if I take 5 cross 5, then you will be able to see the dilation operation being done in a much more broader level, right? So we have much more greater dilation being done with the same structuring element. The shape is same, only the dimension we are varying, so that we can achieve much more increased structuring element. So we can easily achieve those operations. But whenever you're doing this dilation, we have to keep few things in mind. So first thing is where these kind of dilation operations can be applicable. So after the after your image binarization operation, either thresholding or edge detection, after doing that, if you've come across any unnecessary breaks that have been created after that operation, then if you want to join those breaks, then dilation operation is the operation which helps you to achieve those operation. Or even if after doing those image preprocessing applications you have some intrusions, for example, like this, on your first image you are able to see we have some unintended intrusions which have been introduced. If you have to fill those intrusions to create a much more better solid a image that is available to you, then You may use again dilation operation to achieve that particular situation as well. But the important thing you have to keep it in mind is whenever you do this dilation operation, as you can see in the resultant images, the end result will be enlarged. This means the size of that an end resultant image will be enlarged compared to the original image. So this is something you have to keep it in mind while you are doing those image dilation operation. So if you don't want the image enlargement, means the total size to be enlarged, then we have to go for compound morphological operations, which we will be talking about very shortly. So similarly, we have image erosion as well. As the name itself says, it is totally eroding your complete binary image. It is totally doing the shrinking operation. So for example, as you can see in the image itself, we are taking the same image, segmented image A, and we are doing the image erosion operation. So with the 3 cross 3 square structuring element, so by doing that you are able to see the total binary regions which are your main focus are totally shrinked out right away, right? Similarly, if you want to do much more broader erosion or large level erosion, then increase the dimension. You will be able to achieve the same operation in a simple manner. Now again, here let us understand where these kind of erosion operations can be applicable. So in some of the cases, after doing your image processing applications, so for example, you may be doing the segmentation of different shapes in an image. After doing segmentation, due to the proximity of different objects, you may have got a resultant image like this, where both the different shapes are combined, or joined to each other. But in order to differentiate both the shapes, you may have to separate both the objects, right? So in order to do that, we can easily erode those objects, and we can means we can create disjointment in those objects. So we can easily, whenever you want to split different objects in any binary image, so we can use erosion operation to achieve that. Or even similarly, after some image segmentation or edge reduction operation, there are some extrusions which are not necessary for you, which has occurred now. So now you cannot do any kind of modification in those edge reduction operation or segmentation operation, but you can use morphological, you can take that end result and you can apply erosion morphological operation, and you can easily remove those extrusions in a very simple manner. So that is where that is also one application where erosion operation can be very helpful for you. But again, here also, if you are applying only erosion operation, you have to keep it in mind. The end results will be the object which is of your focus. The size of that object will be much more shorter, or it will be little bit shrinked up compared to the original object size. But you have to keep it in mind while you're applying. If that is not a problem to you, then you can easily apply erosion operation directly without any other complexity, and you can easily bring that end results to be obtained in a very simple fashion. If not, then you have to keep it in mind that we have to go for compound morphological operation to retain those original size as it is. So now let us understand that particular aspect as well. So let us understand what you mean by image opening, which is one of the operation available in the compound morphological operation, right? So when I say image opening, whenever I am doing image opening operation in the morphological operation, what I'm doing here is basically I'm taking that binary image, and in the first step, I'm doing image erosion with a specific structuring element, and followed by which, using the same structuring element, or depending on your application with a modified structuring element also, if I do dilation, then basically whenever I'm doing this erosion operation followed by a dilation operation, the operation that we are doing here is basically called as image opening operation. Similarly, we can do the opposite also. So we can do dilation at the beginning, then followed by that we can do erosion operation also. That particular operation is basically called as image closing operation. So this is the basic understanding or the basic concept behind the compound morphological operation. So as I told before, it is basically the combination of the fundamental morphological operation, but in a particular order. So if I do erosion followed by dilation, then it will becomes basically opening. If I do dilation followed by erosion, then it will basically become the image closing operation. As simple as that. Now again, let us take a small example to understand where these kind of image opening and closing operations can be helpful for us to understand that. I have an image, as you can see in the screen. So this is the binary image I have here. And if I take a structuring element of 3 cross 3, and if I just apply that to this, and if I do opening operation, then you will be able to see this is the kind of operation you will be able to see. So if you remember the order in which you will do the erosion, the opening operation, so it is basically first it will do image erosion, followed by that it will do dilation operation, right? So since it will be doing image erosion at the beginning, there are two different shapes that are available in this binary image, right? But those two shapes where we have a small link here, since that is a smaller region, due to erosion, that will be totally eroded out. And even the extrusion which is available in the second shape here, even those extrusion, and even where is a small blob of white pixels, even that, all those region will be totally eroded out. Even in the first shape where we have sharp edges, which is also basically an extrusion, even those will be eroded out completely. And we will, in both the shapes, will have shrinked size. But since I'll be doing the dilation operation with the same structuring element, I'll be able to retain the original shape of both the objects as it is. So I'm able to remove the extrusions which were unnecessary, even those blobs which were present unnecessary, and even the I was able to separate both the objects. But even though after doing that erosion, I was able to retain the original shape of both those objects as it is. So this is how you can easily make use of compound or morphological operation, and you can do those dilation and erosion operation. And even though by using the opposite operation, we can achieve the size of the objects to be maintained as it is. Similarly, I have took the same image and I have applied the closing operation as well to show you how the closing operation basically works. So this is how the resultant image looks like. So by using a 3 cross 3 structuring element for this, so I was able to apply it to the complete image, and this was the end result I was able to get. So if you remember, so it is basically dilation that will be the first operation, which is one of the core aspect which you have to keep it in mind. Since the dilation operation happens, all the empty spaces which is present here will be filled. So this particular region have been filled with white pixel. Even this small blob of black pixels in the second object has also been filled with white pixel. And the end result after that will be the enlarged size of this image. But since we have to retain the original size as it is, and since this is an enlarged image, we can shrink it using the erosion operation, right? So closing operation will do that particular aspect itself. Since it will take the same structuring element now, and it will do the erosion operation. By doing that, again here also, I'm able to maintain the original shape of both the objects as it is, even though after doing the basically the dilation operation. So that is how basically the compound operations are helping you to achieve those fundamental operation in a much better way. So keeping that in mind, so let us understand how we can do this using the Matlab script. So let us quickly go to that. So this is the script where I'm doing the basic morphological or the fundamental morphological operations, where we are doing just right away. We are not focusing on the change in the size. We are just doing the morphological operation right away. That is not a important that is not a huge headache for us, but most important is to understand how we can achieve these tasks. That is important for us. So in order to do that, so I have this particular file available in my current folder. Let me quickly open that folder. In the break I had opened a different folder for my operation, so let me open the original folder. So this is the file which I'll be using, which is having which is basically JPG image. Even though it is 3 channel images, we were able to see in the PPT, right? We can use that, and even we can achieve the morphological operations in a very simple way. But even though as a part of thumb rule, I'm just converting that to single channel image. But even though, even without doing this also, we can achieve the same operation. But still, as a part of thumb rule, let us keep the image to be grayscale as it is. So in order to do that, I have this inbuilt function RGB to gray. So by using that, I can easily convert this JPG image to single channel image. So once that is done, you will be able to see if I use size operation. So I have only the resolution and the channel is totally empty. That means this is basically single channel image that is available for us. So now for this, by image which basically looks like a segmented image of a banana. So I want to apply morphological operation. I want to reduce the size of this banana. If that is the case, then the operation which helps us to do is erosion operations, right? Similarly, if I want to enlarge the size of this banana, then again I can use dilation operation, right? So let us do one by one. So in the first case, whenever you are doing any morphological operation, as we had discussed in the PPT, the first thing we have to define is the structuring element, where we define the shape of the structuring element and the dimension or the size of the structuring element, right? So that is what we are doing. We are creating a variable called SC, where SC stands for my structuring element. And to create the structuring element, so we have to use this function called as strel, where strel basically stands for structuring element. And in that we have to set the properties of that. The first property will be the shape. So in my case, since if you see the shape of the total region, and if you can find out how this look like, most of the regions are basically curvy edges, right? Since that is the case, I'm keeping the structuring element to be circular, or in our case, the Matlab function to define the circular shaped structuring element, the property we have to give here is called as disk. So by doing that, we will get easily the circular structuring element, and along with that we have to define the dimension or the size of our structuring element, right? So here you are able to see I have a simple user defined slider, with the help of which I can easily vary this dimension. In our case here it is having the value 8. That means right now the structuring element dimension will be 8 cross 8. So that means basically I'm using a 8 cross 8 circular structuring element to do the operations. Now, the first step I'll be doing here is I'll be applying the image dilation operation. So in order to do that, so I have this inbuilt function called as image dilate. So which basically easily helps me to do the dilation operation right away. The minimum input you have to give here will be the um, image which you have available here for morphological operation to be applied, and also the structuring element, so with the help of which the actual morphological operation basically happens out. That's all. By doing that, so we can easily get the resultant image. In our case, I have the resultant image in the variable called I underscore dilate, where we have the dilated image available. So now I'm using a simple subplot function to plot both the versional image as well as the dilated image. And in the end resultant window, you will be able to see the first window we have the versional image of that segmented image as it is. And in the dilation, you are able to see all the regions are enlarged, in a very simple way, right? So if I want to enlarge a little bit more, so you can increase the dimension of the structuring element, or if you don't want that much amount of dilation enlargement to happen, then you can also reduce the structuring element a bit. So depending on your end result, you can easily reduce the dimension of the structuring element or increase depending on your requirement, and you can get the end result right away. So that is how you can easily make use of structuring element in any dilation operation to give your to bring you the good results right away. Now similarly, in my erosion operation, my achievement here is to reduce this banana shape a little bit, and if possible to also remove this stalk part in this banana. I don't want that if that is the case. So I can use erosion operation here to achieve that. So here again, similar to IM dilate, we have a very simple function to achieve the erosion operation. So here it is again IM erode. by using Erode function, EROD. So we can easily do the erosion operation right away. Here also the input arguments are pretty much same. The image with which the morphological operation has to happen, and also the structuring element with which the morphological operation needs to be done. That's all. By applying that, we can easily achieve the end results right away. So here again I have the output element I erode variable where the eroded binary image are stored. So I'm using again a simple subplot to display both the results right away. And you'll be able to see again in the first window we have the actual versional image as it is, and in the binary, in the resultant binary image, you are able to see we are able to reduce the shape of the banana a little bit, and in the stock part especially we are able to erode, but still the stock part is as it is, right? That means the erosion amount of erosion that is happening here is still not sufficient enough. We may have to do a little bit more erosion. In that case we can go back to the structuring element and we can increase the shape size of that particular structuring element a little bit. Yep, you are able to receive this error because we have not executed the previous sections. So let me execute the complete section with this updated structuring element and let us see how the erosion operation happens. Yep, it has executed. Now if you go to the erosion operation, still we have the stock part. So we can increase the structuring element size a little bit more. So let me go to 11 or 12 as the structuring element size. We can do a little bit fine tuning here. So let me go for 12 or maybe 13 also. That should not be a huge change. So let us go back and execute here. And if we see now for 13 structuring element 13, we have that total stock part being removed out, and also the banana shape has been totally reduced, right? So this is how you can make use of the structuring element to fine tune and get the proper morphological operation to be done as per your requirement. So now I was also talking about when it comes to structuring element. So we have flexibility to have various shapes in our structuring element definition, right? So let us quickly open the documentation and let us see. So if I go to the command window and if I use the keyword doc and if I just paste that command and hit enter, we'll be able to easily get the documentation right away, where it will give you the description, all the theoretical part which was explaining to you, the neighborhood operation, everything will be explained here. But coming to the actual important part, so where we can define the shape of our structuring element, so let us focus on that part. So when it comes to that, so we have multiple options available for us. If I go to the input argument, so we can choose the shape here. Let me just show you where we are defining that. Yep. So if you see the complete syntaxes, right, in the creation option, so there are multiple options in which you can choose the structuring element, right? So for structuring element, different shapes. So we have diamond shaped structuring element. We have circular, which is basically disk structuring element. We have octagon, which is one of the shape we can achieve, which is a pre-built shape that is available to you. And we have line as the structuring element, where you can also define the total length of that structuring element, also the orientation, which is basically the degree of the structuring element. And also we have the rectangular structuring element as it is standard m cross n, and also along with that we have the square structuring element available. Even if you are focusing on 3D images, right, we had also told you Matlab supports 3D image processing, right? We also have 3D shaped structuring element like cube, cuboid, sphere as well. So for all these, we have different tunable parameters for that. For example, if for diamond, we have the element radius. For disk, we have the element radius. And for octagon, again, we have the element radius. For line, we can tune our shape of our structuring element with length and degree. So like that we can easily define our shape's dimension using those dimension elements along with those structuring element in a flexible way, and we can easily achieve our operation in a simple manner. Now when it comes to the all these input parameters, you can easily go through the documentation, and you can easily understand how those basically input parameters basically works, parameters have any inbuilt parameters available to you, or whether it takes any default parameters or you have any tunable options available. So all those things will be available in each and every input argument which is associated with those specific syntax. So based on that you can easily take a call what are the parameters you have to apply, and you can easily try and test out how the resultant value looks like. If you still feel you need much more fine tuning, you can again change the values as per your requirement, and you can easily bring the result in a very simple way. So that is how you can easily make use of structuring element to easily achieve your output in a very simple manner. Now coming on to the next part where we are focusing on the compound morphological operation. So let us quickly achieve that particular implementation as well. So in order to do the compound morphological operation, so we have the opening and closing operation, right? So I'm taking the same image, which is basically the segmented image of banana, as the image where we will be applying these morphological operations one by one. Again here as a simple thumb rule, which is not compulsory, I'm just converting to single channel image. But once that is done, so now we are going for the creation or the definition of our structural element. So we are defining the structuring element again here, the same disk shape structuring element, and we are keeping the dimension of our structuring element to be 35 cross 35. So once we do that, automatically first operation I'll be doing here will be the opening operation. So if I want to do that, so you have the function that is totally available here. So if you remember the opening operation, what it will do image erosion at the beginning, and followed by which it will do the dilation operation, right? So if I do that, you will be able to see. So we are able to, you due to erosion operation. So this top part of this banana has been totally eroded out. Even at the end, the stalk part has been eroded out. But even though followed by which, since we are doing the dilation operation, we are able to retain the size of that total shape as it is. So that is how I'm able to use the image close opening operation. Similarly, I can do image close operation as well. So if I do image close operation for this particular given image, we don't have that much significant kind of changes in the output. It is almost the replication of the same image but with a bit of dilation, that's all. Since in the close operation it will do dilation first and then followed by erosion, so we'll be able to see here due to dilation operation, so the total image is totally enlarged, followed by which, since we are doing the erosion operation of the same shape, we are able to see the total image is almost as it is with a little bit of dilation, that's all. Not that much of a significant change. So but even though for a different binary image you may get a different result, as we were able to see in the PPT as well, right? So depending on the kind of end result we want to achieve, we can choose any of these four operations. Either we can do erosion, dilation, or even we can do image opening and closing to achieve our end results in a very simple way. So the most important thing while you are applying these operation is, so the end result will basically totally depend on the kind of structuring element you basically employ. So that is basically the important part. So now coming on to the actual aspect. So let us take an example. So if I have an image like this, right? And if I want to do the boundary extraction for these kind of images, right? So what are the image processing functions which are helpful for us to do? So if you remember the kind of operations we have discussed till now, one of the operation we have is basically edge detection, right? That is one of the operation which helps you to bring this end result to be available to us. But again, there we have where there we can have some imperfections to be present there, right? So in order to avoid that, instead of using the edge detection operation, we can also use the morphological operations also to do this boundary detection. So I have an example implemented for that. I am taking the same banana image where I will be doing this boundary extraction. So let us quickly see how we can do that. So let us quickly go to the next example here. So in order to do this boundary extraction, as you are able to see, I'm taking the same banana image as it is, which is the JPG image, but again as a thumb rule here. So I'll be just simply converting that to single channel image. The reason why is we are using the morphological operations to achieve the boundary extraction, right? So if I want to do the boundary extraction, so I have both the fundamental operations available to me. Either I can use the erosion operation to achieve that, or either I can use the dilation operation also to do this boundary extraction. So in the first case, I'm using the dilation as the operation to do the boundary extraction. If that is the case, so I'm basically just defining the structuring element. Once that is done, so just take the input image and the structuring element as the input, and first get the dilated image to be available. Once we have that, so we will just subtract that dilated image with the original image as it is. So by doing that, you will be able to see we can easily get the boundary extraction being done for that image. So let me just quickly magnify a little bit and show it to you how the output looks like. So let me magnify here a little bit. So now you are able to see, right? So we have the boundary extraction being done in a very simple fashion. Similarly, even if you want to do the boundary extraction using the erosion operation, we can easily do that as well. So here in the erosion operation, so again here also we are just using the structuring element and we are doing the erosion. And once we do that, we are subtracting the original image from this eroded image. That is the only change you have to do. By doing this also, we can get similar kind of output in a very simple fashion. So there are multiple image function, processing functions like this, with the help of which we can do this kind of boundary extraction being done in a very simple fashion. Now, similarly, we will take one more simple example. So where we are applying these kind of image processing functions to achieve a end result. So as you are able to see in our script here, our end result is to do the cell detection. That means we have to do the segmentation of a cell, which is basically a image that is available here of a cell. So which is basically from a particular university which we are able to achieve, take this from. So I'm also adding that particular information, but that is not the important for us here. We have the cell's microscopic image of that cell available, and I want to segment this cell object. That is the end result that I want to achieve here. So in order to do that, so I'm using different functions. So if you are able to see the description here, I'll be using two operations. The first operation I'll be using here is the edge detection as the first operation, and then followed by that to remove the imperfections, to fine tune our edge detection result, we are also applying the morphological operation followed by that. So let us do this and let us see how we can do. You are able to see I'm doing multiple steps. So for each operation, I'm having the step by step description what I will be doing here. So let us go through that step by step one. So basically using IM read. So I'm loading the image, and using IM show, I'm just displaying the image. And once that is done, so this is the actual image. So I have verified. So once that is done, automatically the next step is to achieve the edge detection operation, right? So since we are focusing on the cell, and since that cell is a complete shape and not any part of a internal intricacy that is present in an object, So we can make use of Sobel operator, which will be able to sufficiently do that, right? If we had gone through that particular example for the coin edge detection, so we can easily do that. So I have already done that here. And what I'm doing here is, so parallelly, I'm also taking the thresholding value that it is, doing for our edge detection, and based on that, I am doing my own custom thresholding while I'm doing the basically this edge detection. What I'm doing here, so I'm taking the threshold value, I'm taking a edge factor. Sorry for this particular, it has become a fudge factor here, not fudge factor. Basically, this is a edge thresholding detection factor. So I'm keeping the edge factor to be around 0.5. That means whatever the actual thresholding this will take, I want that to reduce by zero point 0.5 by a scale of 0.5. And whatever the thresholding value that will be available for that particular scaled value, I'll be using that updated value for doing my thresholding. So that is what I'm doing here. I'm just doing customization for the thresholding value. So I'm reducing that thresholding value by a factor of 0.5. And how I can do that? Basically, I can multiply that edge factor by using this computed threshold value, right? So we can easily do that. So once we do that, automatically we can easily achieve that operation in a simple way. Now whatever the result I have got here, I just want to visualize that using IM show. So I can easily do that. So by using the customization threshold operation, so I was easily able to get this kind of result. Actually, by using actual Sobel, I was able to get much more distorted image. To reduce the distortion a little bit, I reduced the edge detection factor, thresholding factor by a scale of 0.5. And by doing that, I was able to get this kind of resultant image, which I felt much more better. Yes, this is still not perfect, but still up till this point, I was happy with the kind of result I was able to get, because I have morphological operations and other kind of inbuilt other kind of image processing functions available, which will be helpful for me to refine this result a little bit, right? So keeping that in mind, the next thing I did is I used the image dilation operation. Now you can ask me why I'm using the dilation operation here. So if you have gone through the documentation, right? So we can easily define the shape of our structuring element in multiple shapes. And among that, even line is also one of the shape, right? And that is what I'm using here. I'm using the line of length 3 pixels, and I'm using two kind of structuring element. In one structuring element, I'm orienting it to be vertical line, and in the second structuring element, I'm orienting it to be a horizontal line. And I'm using both of those combination of those structuring element, and I'm just dilating whatever the lines I can find in that particular previous image, because all those are multiple lines here. And if I want to segment that, all those region to be filled with white pixels, right? So dilation operation helps me to dilate those lines, right? So I'm just utilizing that. And once I do that, you'll be able to see I have much more better segmented image here, right? But even though there are some extrusions here, that is fine. We can remove that by morphological operation. And we also have some intrusions or empty black pixels. We can also overcome that by using image processing functions. So this was a much more better result I was able to get. At the first thing I used a horizontal line as a first step, but still I was not able to get better result. And through the documentation, I was also able to see I can orient that particular line by 90-degree as well. So I thought, why I should not use combination of that. Let us see whether I can try the combination of both the structuring element. And I tried that, and I was able to get this result, which I was happy with. At this particular level, it is still not perfect, but yet with this particular operation which I was applied here, I was happy with the kind of result I was able to get. But still there are some imperfections. We have to overcome that imperfection, right? So I was able to go through the documentation of the functions, multiple functions that are available in the image processing toolbox, and I came across this interesting function which is basically called as IamFill. I opened the documentation. I was able to totally understand the complete documentation, And here, if you see the description here, I'm using this function to fill the blank holes that are present here. So right, b1, those regions has to be filled with white pixels, right? So in order to achieve that, I'm basically using this fill operation, and wherever there are empty black pixels within this region, so now you are able to see all those empty black pixels are now totally negated, and we have a complete segmented cell available to us. But still, it is still not perfect. One reason is we have some extrusions that are available in the cell region, and also we have a partial cell available here. We don't want that. We want only this complete cell to be segmented. So let us overcome one by one. So I used once again the image processing documentation to identify various image processing function, and I was able to come across this function called as clear border, which basically, as per the description of that complete documentation, I was able to understand, okay, I can use this function to remove this partial cell. So in that, we have to basically tell the total pixel connectivity around the major region, and we have to give the original image, and wherever it is able to on the borders, wherever it is able to identify these kind of large region, it will totally remove those connected cells completely. So that was the description I was able to understand with the documentation. So it basically fitted with my requirement. Since that was my case, you're able to see I used the minimum dimension of the pixel connectivity, which is basically available to be 4. Then we have a higher pixel connectivity values as well, 8 pixels, 16 pixels. You can increase depending on the image resolution you have, but in my case, 4 pixel connectivity was more than sufficient for me. By utilizing that for border removal, I was able to easily remove that partial cell which was present in my original image. Now I have only the actual complete cell to be available in my segmented image, right? But still, it is not complete segmentation. We still have some imperfections present in this, like small extrusions are there, and we have some minor intrusions. So we have to remove those one by one. So in order to do that, so we are using some operation here. So in the first case, I'm using the combination of erosion operation. With the help of that, I'm easily able to remove the uh, simple extrusions that are available, and also if required, if you feel there are any particular further intrusions also, if you want to fill out, you can make use of, once those extrusions are removed, you can easily make use of dilate function also. But in my case, I felt this is much more better result, so I have considered myself that this is the segmented image of the cell that is available in my original image. Now we have to verify that, right, whether we have segmented properly or not. So we have multiple options for us to verify our result. So in our first case, I'm using one of the option is to overlay our segmented image on top of our original image, where we can get a false image, like this, where we have the actual grayscale image and we have this region where we have this segmented cell. So I'm laying on top of that original image, and you're able to see I'm able to sufficient successful segmentation, right? So we can, if you don't want to verify like this, if you want to do verification in terms of perimeter, we can also do that as well. So we have that function available for us to achieve that. So we have this function called as black and white perimeter function, bw perimeter. So I took as the segmented image as the input, and whatever the perimeter outline I was able to get, I filled all those particular image with the white pixels, so that I can see the outline of that complete segmented area in the original image itself. So in the original image, so this white line, segmented line, white outline you are able to see is the segmented region. I am able to do the segmentation or the detection of the cell region in a very simple fashion. So this is the binary mask we are able to achieve. So using
Sir,
this, we
I
can.
have one doubt, sir. Can I ask?
Yeah, yeah, please, ma'am.
Sir, in the previous result, there are two images now, sir. We cannot avoid the original image.
Uh, which one, ma'am?
Here, sir, here we are getting two images. One is somewhere very small and the other blue one. So we can't avoid this, or we need to have both the images.
No. Let me clarify you once again, ma'am. This is a verification, means this is a verification step. Once I have successfully done the segmentation here, what I am doing in the final step here is I am trying to verify whether I have done the successful segmentation or not. So in order to do that, I have two methods. So this image which you are able to see here, right, is the technique where I'm using a particular function called as image overlay function. And using that image overlay, I am just basically taking the original image and I'm just putting my segmented image on top of that. Just I'm doing that. By doing that, I'll be able to verify whether I have been able to successfully segment that region of interest successfully or not. And you're able to see we have a false color image, blue color image available here, right? So this is basically showing me that this is the region which you have successfully segmented. And by doing this, you are able to see we have almost successfully segmented that complete cell region in a very simple fashion. Along with that, we have also one more alternative method. So this alternative method is where I will not do any overlay. I will just take that segmented image. I will just measure the outline region of that. And for that outline region, in my original image, I will fill that area with white pixels. So I'm taking the original image, and with the outline image, whatever I'm able to extract from the segmented image, for that particular outline perimeter, I'm filling with 255, which is basically the white pixels, right? By doing that, in this new set of image, you are able to see here, I am not overlaying anything. We have the actual original image as it is, and we have the white border available here, right? So this white border tells me that what is the kind of segmentation we are able to do. This is one more technique that is available to verify the kind of segmentation we are able to do. So this is an alternative technique, not compulsory that we have to use both the technique. Whichever the technique you feel will be good for you, you can use that technique, and you can make sure you are verifying the segmentation in a proper way. That's all. This is a optional step that is available for you. The step 7, which I'm demonstrating here, is not compulsory. It is a visualization option that is available for you to check how the segmentation you have done compared to the original image. That's all. I hope I have answered your question, ma'am.
Yes, sir. Yes, sir.
Yep. Thank you very much, ma'am. So using our image processing functions, you can achieve various other kinds of applications. So now I will take quick 5 minutes of time to give you the overview of image processing toolbox, how you can access, I was talking about multiple image processing functions, how you can quickly achieve that, how you can focus on those functions, and what are the other resources that are available when it comes to image processing toolbox. So you can easily open the documentation in a very simple way. You can go to the home tab, and in the home tab you have this function, you have this option called as help. You can click, automatically it will open you the complete documentation that is available. So here you are able to see I have access to multiple toolbox. So depending on your case, whatever the toolbox you have installed, so you'll be able to see the complete list of those toolboxes in your case. So in that you have to focus on the letter I. In that letter I alphabetically, if you go to that, you'll be able to easily identify the image processing toolbox. If you click on that image processing toolbox, you will be able to get this particular documentation being available. So whatever I was talking about, like simple import export and even conversion operation, right? And along with that, even if you want to focus on image registration or geometrical transformations for your image, how you can do that, what are the functions that are available, we have a dedicated section for that. If you're focusing on image filtering aspects, we have a separate section. Along with that, even we have options for image enhancement operation, so that you will be able to understand the contrast adjustment, morphological operations, so image blurring and deblurring, and even your region of interest based filtering applications in a very simple fashion. And for image segmentation and image analysis, we have other section as well. And for your deep learning applications, which will be focusing on session 3 on on January 19th. We'll be discussing on these deep learning applications as well. So we have a separate section. And for your 3D image processing and hyperspectral images also, for people who are working on hyperspectral images like satellite images or even other multiband images, so we have this hyperspectral image processing functions are also available to you. And for even one of the audience was asking how I can deploy my applications for my particular FPGA tool. So we have this code generation support also. I recommend that faculty to go through the code generation support which is available. So you can do standard C++ code generation using this link, and you can also focus for your HDL code generation for your target FPGA device using this HDL code generation support. So you can deploy these applications on GPU as well. So depending on your particular target code hardware, you can use the specific coder product, and even you can do code generation and do the quick deployment of your application in the hardware as well. So if you are focusing on embedded hardware, then standard C++ code generation should be good enough. And if you are focusing on FPGA hardware, then HDL code generation will help you. If you are focusing on the CUDA code generation, then GPU coder will help you to achieve that particular aspect in a very simple fashion. Now, along with that, so if any participant still face any kind of issues in those aspects as well, it is pretty much common. Then in that case, I'll be giving you my contact detail. I'll be giving you my email ID. You can contact me at any point of time. I'll be happy to take up your queries, and I'll be happy to help you with the sufficient suitable resources as much as possible. Now coming on to that, along with the standard documentation for the workflows, we have the examples for those specific workflows as well. So if you go to the example section, it will take a few seconds of time to load those examples, and by doing that, you will be able to see all those multiple range of examples available to you, depending on whichever the kind of examples you want to focus with. You can easily open that documentation. For example, maybe you are doing the object detection operation, for example, maybe, and you want to detect cars, right, in a video file. So that is example automatically available here. You can easily open this documentation. And also if you want to directly open that example as a script also, so you have this option available here. You can click on open script, with the help of which you will be also automatically getting that example available right away, and you can go through the complete workflow. And for your particular application, whatever the modification you want to do, you can do that. And there was also one particular faculty who was talking about support for Dicom files, right? So we have multiple functions available. Like if I want to see the complete Dicom files available in a complete collection of directory, I can do that using Dicom collection. For reading my Dicom file, I have Dicom read. Similar to IM read, I have Dicom for Dicom files. For medical images, I have Dicom write and Dicom read also. So I will be showing you that in the documentation as well. No need to worry. Let me go back to the documentation quickly. So after going through the examples, even you have also something called as functions, right? So you can also, if you want to see what and all the functions that are available for me in the image processing toolbox, if you want to go through that completely, let me magnify this screen a little bit, and you'll be able to see we have multiple functions, and all those functions are segregated in multiple sections. For example, see, if you're focusing on medical image, which is basically Dicom extension files, right? We have a collection of functions which helps you to work with those files automatically. So you can use those functions, and you can easily import your Dicom images and apply those apply standard image preprocessing functions right away. And if you're working with raw image files, when you have this raw files, raw file based functions available for you. And if you're focusing on specific file formats, even you have the functions that are available for you right away. So you can use all these functions, and you can easily work with your image processing in a very simple fashion. So let me go back to the standard documentation, where I'll be having the documentation for the image processing completely. Let me go back a step. Yeah, let me go back to this image processing, and now let me open the function, because now this was showing you the documentation which was filtered for that particular application. Now here, if you see the complete documentation, right, there are more than hundreds of functions. So no need to remember. So use this particular documentation, and you will be able to easily identify the kind of application you want to focus with. For example, if you want to do image conversion from maybe one format to other format, you will be able to easily understand what and all those conversion operations that are available for me, and how I can utilize that. Even if you click on that, the complete documentation will be available for you in a very simple way. So even for our thresholding, we have multiple functions, right? So you can use those multiple functions, and you can you can do your specific thresholding applications as per your requirement. So Otsu's algorithm and gray thresh and IM binaries are only the examples I had shown you as per the demo. But even you have something called as adaptive thresholding, where you can do local thresholding and global thresholding as well. So if you want to do that, you can go through the documentation of adaptive thresholding, and you can do that as well. And even there are multiple different functions you can do. So I'm just highlighting you few set of functions that are available here. But depending on your requirement, you can go through the complete documentation, and you can focus on that specific area you are working with, and you'll be able to easily identify that the collection of functions which are helping you to achieve those operation. And you can go through the documentation of each function as per your requirement, and you can start utilizing that functions and bring your application into reality in a very simple fashion. So even that is what I will do as a user of Matlab. So I don't have any necessity. Even Matlab documentation tells that there is no necessity for you to remember all those functions. Use the documentation and utilize bring your application into reality in a very simple fashion. Similarly, so if you are very new to the this Matlab or even image processing, and we'll be quickly also talking about the machine learning application in the short while, within 2 to 3 minutes. So even for those applications as well, so we have the training courses that are available, which are free of cost. I'll be talking about that at the end section as we go forward. So coming on to the next part now, so we'll be focusing on machine learning application. So now, since we have only few set of since we are focusing on that, let me give you from generic examples where we can where and how this machine learning toolbox can be used. So one of the applications where this machine learning application will be useful is in terms of clustering your data. Now, what do you mean by data clustering is that, so you have a data set available to you, and you have multiple features available in that data set. And based on those features, you have to do grouping of your data based on that particular features. You have to do grouping for your data. If that is the case, then basically that particular application is called as clustering application. So let me just quickly give you an overview on how we can do that. So to do that,
Atul, the session is going on dimensionality reduction, man. Hmm?
uh,
No,
s-
now they
do we have
started.
a question here?
FTP, dimensionality reduction.
I think mic is on.
Yep. I request the participant, if there are no question, kindly please mute your mic so that there will be no disturbance in the session. Yep. Thank you very much. So now let me just quickly navigate myself to the folder where I have the supporting files for my machine learning, so that it will be easy for me. So the kind of file which I'm using here is basically looks like this. Sorry, I'm opening this in the MATLAB export window. Let me open outside MATLAB in the actual Excel sheet very quickly and show you what is the file I'm using here to do this data clustering application. Yep. So this is the kind of file I'll be using, and you'll be able to see we have the name. This is basically a basketball player data, We have this is available in most of the dataset websites. So whatever the examples I'm using here, these datasets are available in most of the public datasets website. So in my documentation, in my particular file here, I'll be giving you that particular link as well as I'll be sharing where you can download that particular dataset as well. But in our case, I'll be showing you how to overcome, means how this particular dataset looks like very quickly. Let me give you a quick overview of that. So this particular data set has multiple information like what is the player name, what is the kind of position in which that particular player plays with, and what is the particular grade points he has achieved till now, and what is the kind of what is the kind of height, what is his weight, how many number of minutes he has played, what is the total points he has achieved. There are various number of data points or features which are available for me in my particular data set. Now my goal is to identify these particular using these features, I want to group this data into multiple clusters. So that is my requirement. So since I know a little bit about basketball, so in my case, I am expecting at least a ballpark clustering in terms of 3 cluster. One cluster where we have the clustering in terms of forward players, one cluster in terms of the center position players, and one more cluster in terms of the guard position players, because that is the major position in terms of basketball. Since I know that, I'm using that particular data set which is relevant to me to demonstrate you to do the clustering example. I have not done any clustering till now. I'm just having a ballpark expectation, which I'm expecting to get at the time I will be doing clustering implementation. Now, when it comes to doing clustering implementation, there are two techniques we can apply. One of the technique which helps us to do is basically both the techniques which which will be helpful for us to do is basically the dimensionality reduction operation. But in turn, those dimensionality reduction helps us to do is automatically indirectly is helping us to do the clustering as well. How it is doing us, I'll be showing you in a short time. No need to worry about that. But let me quickly talk about the one of the technique which is available here. One of the technique we'll be utilizing here will be called as classical multidimensional scaling technique, and one more technique which we'll be utilizing for our clustering application will be called as principal component analysis, which is popularly known as PCA technique. So these are the two techniques I'll be utilizing here. So here basically since this is an Excel sheet and I want the data to be available in table format, so I'm using this function called as read table, and I'm just passing that Excel sheet file name basketball data process.csv, and also along with that we are just defining the different categories or the different labels that are associated with our data. The reason why we are defining this is because we'll be comparing this with the parameters, and we'll be doing the dimensionality reduction, and we'll be finding about among all these labels which are the key labels which are helping for us in terms of the features that are available, and using that labels what are the different clusters we are able to achieve, we'll be utilizing that. So we have multiple positions like guard position, guard, forward. So I know those positions and I'm just defining that these are the different positions a player can play with. So guard or guard forward with the priority to guard, and forward guard with the priority to forward, and forward position player, and forward center position or center forward position, or even actual only center position player. These are the different positions or the player can can play with a particular positions. So once I have that, I'm just including that in my table as position names. So this particular column is available after including this. So in the actual data in the actual data set, this will not be available. So this I have added as I know the multiple positions which are available. So in the Excel sheet also you were able to see that column because I had added that table and I had extracted that CSV folder myself. Now once we do that, so we can easily do the first thing we have to do whenever we are applying either the PCA technique or the classical multidimensional scaling. The first thing we have to do is we have to normalize our data set in a simple manner. So in order to do that, so we are just taking our option. So in our case, the actual, if I see the Excel sheet, the actual numerical value starts from column number 4 until the end column. So until then, there are no any numerical values to normalize. Since that is the case, I'm just telling this particular normalization should happen in the table starting from column 4, and for that particular index, so I'm just utilizing this normal function. So I'm just creating this index here, and for that index I'm just doing this normal function. So normalize is the function, it is automatically available to you. So normally we will take the maximum value that is available in each cell, and we will divide that by each values to normalize, right? But here no need to do that manually. So this normalize function which we are applying here will be able to do that, and we'll be able to easily get the normalized function automatically. So in order to show you that, let me execute the script, and let me quickly show you how the normalized function will be available to us. So give it a moment. In my case, it is executing, and very quickly in my workspace, this particular stats norm, which is my normalized output, will be available. Yep, it is available in my case. Let me open this stats norm here, and you'll be able to see all the data values which were available there here, starting from column 4, so have been automatically normalized. So and you'll be able to see we have values in terms of -1 to 1. So this is a simple normalization we have here, and we have the normalized value available to us right away. So even if you now, let me go to the actual magnification. And now the first thing we have to do here is, so whenever we are using the classical multidimensional scaling, we can't directly apply the normalized value as the input for our dimensionality reduction. For us, we have one more step we have to do. So that is, we have to calculate the pairwise distances for our normalized data set. So here also again, no need to use any inbuilt function to do that. We have this function available called as pdist, which will be able to calculate the pairwise distances for our data set. And we can just pass the input, which is our normalized data, for our function here, and it will be able to calculate the pairwise distances, and the output will be automatically available. Now we have to use that as the input. The pairwise, whatever the pairwise distances we are able to achieve here for our data set, that will be the input for our classical multidimensional scaling function. So the function here is CMD scale. So we can get multiple output values from this CMD scale. So let me just show you what are the output values you can achieve. So let me quickly open you the documentation, so that you can quickly understand that how we can utilize this. Yep. So you'll be able to see majorly at the end we have compulsory output you can achieve is the output Y. So which will give us basically the total output. But along with that, the classical, the dimensionality reduced output. But along with that, we also have one more optional output we can achieve from this, which is having the name E. So this E will give us basically the confidence, the score output, which is basically the eigenvalues for our, the dimensionality reduction that is happening. So let me show you what are these output and how it basically looks like in our Matlab, script. So I'm extracting both those outputs. So I'm extracting both Y as well as the E output. And in the first output, you have the dimensionality reduced, output being available for us. And also we have the associated eigenvalues being available here for all those 1112, data features in that. So if I want to visualize, so what are the key features which are helping me to as a part of in terms of feature description. So we can use this visualization function called as Pareto Chart, which easily helps us to achieve the visualization here. So we are using that function Pareto, and we are passing that eigenvalue vector. And if we do that, you will be able to see. So the vectors which are majorly having non-zero values in terms of matching with the features are basically out of 1102, majorly 8 features are only having the non-zero values, and remaining all the features are having almost zero values. And if you are able to see in terms of major matching, so the first feature is contributing almost towards 42 to 45% in terms of the features, and in terms of the complete data set. And the significance of feature 2 is approximately around 25 to 30% in terms of the complete features which are available. So majorly the first 2 to 3 features which are available to you here, if you consider that, it should be helpful for us to easily do the clustering in a very simple fashion. So with those particular features being taken into consideration for the data points, so we should be able to do the clustering in a much more simple fashion. That is what my Pareto chart is able to tell me. Even if you are going for classification or regression application, the context which I'm taking here, which should be sufficient, the same. So the first 2 to 3 features should be able to achieve the end result which you're able to achieve. So that is what it is, this particular chart is able to tell me. So keeping that in mind, I'm taking the scatter plot of the data points considering only those 3 features, and this is the plot I'm able to achieve. Still here we are not still able to visualize the clustering. That is not at an issue because we have one more technique which is basically called as PCA, right? So I'm utilizing that. Let us see how I can do PCA technique to do the dimensionality reduction. So PCA is straightforward function. No need to do any other calculation like pairwise distance and all. If you have the normalized data available to you, then it is more than sufficient. We can automatically apply that and we can get the end result available. So we also have the output available in a very simple fashion, similar to the vector E which is available here. We have the vector p exponential which is available to us, which is basically similar to the eigenvalue vector which is available to us. So we can use that. Once that particular p exponential you are able to get, you can easily take that and pass into the Pareto chart creation function, and by doing that you will be able to get a simple graph. Here also, since we are using the same data, we are getting identical results here as well, but with a little bit variation compared to the previous classical multi-dimensional scaling, but not significant variation, minute variation here and there. But the end result is again here also again pretty much the same. Out of all the various output we are able to get, only we are able to get non-zero score output only for the 8 dimensions out of the various 1112 dimensions which are in 1112 data points we are able to get. And among that, so we are the major features will be the first 3 features which is taken into consideration here, should be more than sufficient to give you the best results. So here again I'm plotting the scatter plot using that particular first, second and 3. If I take the scores and if I filter out, and you will be able to 3 in my 3D scatter plot, we are able to get similar kind of graph which is almost pretty much same compared to the classical multidimensional scaling result. So in order to verify that, I have plotted the results in a simple chart here, and you are able to see either you go for CMD or whether you go for CS PCA technique. We are able to get this kind of scatter plot function which we are able to get here. And in that, what I'm doing here is basically, so I'm just taking the position names which I had created at the beginning, right? And I'm just extracting that I'm just telling that whatever the data points we are able to achieve here, just group that in terms of the data position we are able to achieve here, and just assign colors to those data points in a simple fashion so that I can see what are the different clusters we are able to achieve here with the help of this function. And if you are able to do that, so we are basically able to see, so among all the data points here we have multiple colors, but if we see the major colors here, we can easily achieve the we can easily able to see the kind of clustering we are able to get. So there are multiple colors in the shade of blue, but the major shade is in terms of navy blue color here, right? So if you see that, we have the color chart which has associated that color in terms of different positions which I had defined at the beginning, right? So that navy blue color is belonging to the cluster of the guard position. So that is one of the cluster we have, which I had expected. And we have second cluster in terms of the aqua green color, sorry, not blue, aqua green color. And we have different shades of aqua color here, aqua blue a little bit, and also a little bit green color as well, but majorly we have this aqua green shade as the major number of data point. And if we focus on that, we have this section here where we have this F, right? So which is basically forward player position. This is one more cluster we were able to achieve here. And similarly, we have the yellow color points here, right? If you see the color chart, that is belonging to the center position players. So basically at the end, whatever the player may be, at the end we have three set of clusters we are able to achieve. One is center position players, one is the forward position players, and the guard position players. That is totally available. So using these kind of techniques, we can easily do the clustering. So these are not the only two functions that are available. So if you are interested in terms of soft clustering and hard clustering, we have multiple other clusterings as well. So I can share you the necessary documentation. We can go through that and you can make use of those soft clustering and hard clustering algorithms for your particular application implementation as well. But this is one example I just wanted to show you as a part of machine learning toolbox. So we can easily do the unsupervised learning process where you can easily do the clustering for your given data set right away without any issues. Now, one more example, which I'll be, going through in a very quick way, is basically your exploratory data analysis setting, which helps you to refine your data set, because most of the data set which you will be handling may not be completely refined as it is. Whatever the data set you may receive, there might be some imperfections here and there, similar to the way in which we were able to see. So, so in this particular case, if you are able to see, the kind of data set which I'm able to achieve here is having the name train and test. So if I open that, you'll be able to see there are multiple empty cells that are available in my for example, I can take train set only and I can open outside Matlab as the original Excel sheet, and you'll be able to see, for example, here or here. So there are multiple cells where we have empty cells, or even in this particular region here. So there are multiple empty cells that are available here. So even in your practical case also, while you are capturing the data from any sensors, or while you are taking any data set from any available website, you may come across a situation like this where you have these kind of empty cells. So that is where this particular example shows you how you can refine that particular example, where you can use simple techniques to overcome that missing cell situation. So you can go through this particular example and you can easily identify. We are basically using the equivalent value substitution technique to overcome the missing value problem that we had here, and we were able to overcome for the column age, and we use some image processing technique to visualize whether the missing value is only limited to age column only, and we were able to see yes, it is not only limited to age column. We also have two different other columns like ticket and cabin where we still have missing values. So I'll be leaving that task up to you. You can use similar other techniques like modal analysis and other techniques, with the help of which we can easily overcome that in a very simple fashion. Similarly, the next example I had shown here is the Eda technique, with the help of which we are basically trying to find out there are around 12 number of features which are available in our data set. So among that, which are the features which are best suited for my particular application? So while I was developing this workflow, I had intended that I'll be developing a machine learning classifier which will be able to identify whether this data set. Let me give you a quick explanation. Is basically popularly known as Titanic data set. It is available in most of the popular websites. Once again, you can find out and download it. I have also given the documentation where you can download that yourself. So you can do that. That is not a huge issue. But this data set is basically, using this data set, my goal was to come up with a classifier which will be able to identify whether that passenger has survived or not. So that is the kind of model I wanted to develop. So using that particular thing, so I used multiple histogram, multiple EDA techniques, which helped me to identify, whether a particular input feature will be suitable for my application or not. So using different features, I was able to find out that if I use fair as the input feature, I will not be able to get good result, because in both the histogram plots, I was able to get ambiguous result. That means common result in the case where the passengers were survived, and even in the case where passengers had not survived. So I changed the, I came across multiple EDA technique. We have one more function called as group statistics visualization, with the help of which I was able to find out for that part, in terms of, the visualization output, I want the statistics output for survival status and the gender, and the grouping has to be done in terms of gender. So that is what I had given the information, and with that I was able to get this kind of output, which was able to tell me in my complete data set there are two groups of genders that are available, male and female. And when it comes to male, there are total 577 number of samples available in my complete data set. And when it comes to female as the data group, in that group we have total 340 number of samples available in the complete data set. And among that, if we have a statistical output for our survived, which is survival status, which is basically our mean value. So which is basically telling me that out of my 577 samples, around 18% of passengers have been survived, and remaining passengers are non-survivors in my complete data set. In similarly for the group female, in my complete data set for my female group, so out of 314, around 74% approximately we have survived passengers, and remaining passengers are non-survivors. So whether this EDA technique was good, if you ask me, I will say good. This is why, because whether I will develop a machine learning model or not, I now have a ballpark, expectation I can expect from my machine learning model. That is, it should be easily able to tell the survival status very easily when it comes to a male and female, because it is evidently showing me that the survival status of female is more compared to male in our complete given data set. So given that is the case, they should be able to, if I take the gender as the input feature, it should be easily able to learn the respective feature in that given data set, and it should be able to give me a very good result. So now I have also set other set of tasks. So that is whether only this gender is only the feature which is suitable for you, whether you can find out whether any other suitable feature along with this gender for you for your survival predictability model, and along with the age versus survived, can you plot histogram of age versus survived, and can you find any interesting usual suitable information from your data set. So that is what this particular script is all about. So how you can find suitable information from the data set yourself before you actually do your machine learning or deep learning application. So doing your EDA process is a very good pre-processing that you need to do. So that is what I was explaining in the I have taken in this particular example. So I have gone through multiple steps. So I have also left multiple other steps to the audience itself, so they can go through the script and they can also try out those steps by themselves. If they come across any question at any point of time, they can feel free to contact me. I'll be happy to help them in a very simple way. Similarly, when it comes to the machine learning toolbox, so whatever the machine learning model you develop, you have the option for you to visualize the decision boundary for yourself. So using simple scatter plot, once you develop the model, you can easily predict the result, and with the help of predicted result, you can easily plot the scatter plot for multiple machine learning algorithms, and you can easily select whichever is the best suited model that is available to you. And it is not necessary that you have to do this in program only. You can do that even automatically, similar to the image processing inbuilt apps. Even for our machine learning and deep learning, we have multiple inbuilt apps that are available. If you are focusing on your classification application, we have classification learner. If you are focusing on regression applications, we have regression learner. I'll be talking about how you can utilize these applications in the next session as well. We'll be focusing on deep learning application. Before we start our deep learning application, I'll be giving you a quick overview how you can utilize this classification learner and deep learning learner, regression learner app, and then we will move towards the deep learning application, because using that app requires 5 minutes for a given application. So I'll be showing you that very quickly after in that session as well. So this is a script. I'll be sharing it to you. You can use this before I go to the session. Using the script, you can also go through that particular workflow yourself, and you can try it out for my data set which I'm utilizing here. Or even if you have your own custom data set, you can also load that, and you can also try out using the classification or regression learner app, and you can see how you can utilize that. Now, along with that, so we have one more simple application in my case, where I'm using the image processing as the basis for implementing our machine learning application. So let us take 5 or 10 minutes and let us quickly complete this session, and where we'll be focusing utilization of our image processing technique for implementing our machine learning application. So this is an application where we are using image feature extraction technique. So using those technique, we are using a simple classifier. We'll be developing using a classifier model. In that you will be able to see in the description, I have used multi-class SVM classifier to develop our classifier model in a simple way. And our case is to identify the images of digits. So this is basically object classification. In each image we have a specific digit. So we are using a particular popular data set called as digit data set. So in our data set, we are basically loading that data set, and we are just splitting that into training as well as testing. And once we do that, we are just, as a verification purpose, we are just counting the number of data points available for our data in terms of each label in the training as well as testing. And you will be able to see out of complete data set for all the labels, so which is basically the labels for the digits from 0 till 9, we have approximately 101 number of data points or data samples in the training data set, and we have 12 number of data samples in the test data set. So once we visualize this, so we are just visualizing few collection of values in terms of you're able to see I'm visualizing the image for digit 1, and I'm also visualizing the image for digit 3, and I'm also taking visualization for digit 8, and we are just visualizing the output in terms of training as well as test data set, and we are able to see the respective outputs in the training as well as test output. So we are able to see for few set of images we have noisy images. To overcome that, so we are using this I'm binarized technique to overcome those output, and where you are able to see we have the actual image, and after using that image pre-processing, we are able to get much more better binary output here. So we are using batch processing to overcome all that. And once we have that, so in order to extract the actual features, there are various features we can extract from image. And in one of the popular feature that we have here, since each and every image is having a particular vertical or horizontal direction based lines in our digits, since that is the case, I'm using this particular feature extraction called as histogram of gradient, which was helpful for me to capture the necessary output. So why? Let me just show you here. This is a verification step which I used here to identify this is a best suitable feature for me. So the parameter which helps me to control how the feature extraction happen is basically called as cell size. This is the feature which helps me to change the way in which the feature extraction happens. So I used 3 set of cell size options: 2 cross 2, 4 cross 4, and 8 cross 8. And if I just visualize the output for this, so the 2 cross 2, 4 cross 4, and 8 cross 8. So I did this for digit number 2 here. So you're able to see the data set I'm taking here for 206, which is basically 6th image in the digit 2 data set. So you're able to see the digit 2 available here. and also the respective outputs in terms of the features which we have extracted using histogram of gradients. And you'll be able to see that for cell size 2 cross 2 we have 1764 feature descriptors. For cell size 4 cross 4 we have approximately 324 feature descriptors, and for 8 cross 8 we have 36 number of feature descriptors. So by comparing this, I was able to identify that for cell size 8 cross 8 we have very less number of feature descriptors, and for cell size 2 cross 2 we have very high dimension of feature descriptor. Compared to all those three, I was able to identify cell size 4 cross 4 is able to give me the better trade-off, where we have sufficient number of features and also we have less number of feature dimensions. So since that was the case, I chose 4 cross 4 as the standard cell size for my batch feature extraction that I will be doing for my training as well as testing data set. Since that was the case, so I'm doing this feature extraction in a simple way. So before we do that, we have to do some image pre-processing, right, where we are doing the removal of noisy pixels in that image. So we are using that image, image pre-processing, whatever we did in the test, in that initial test phase, we are doing that for all the images here. And once we do that, so we are basically extracting the training sets by using this HOG feature extraction function available, which is basically extract HOG features. So where HOG basically stands for histogram of gradient, which that is the feature extraction technique we are employing here. And once I have extracted the training features, I'm taking that and I'm training my multi-class SVM function, which is available programmatically by using this FitC ECOC, where FitC stands for classification classifier model and ECOC is the name for my multi-class SVM model, which is available for me. And automatically by using that, I'm able to use my training features and using my training labels, which is available in my data set, I'm able to completely train my classifier. Once that is done, I'm able to I'll be I'm extracting my test features as well. So here I have a helper function available for me, which is basically a user defined function which helps me to extract both my test features and train features automatically. Once I'm able to extract the test features and the test label, I'm just using the predict function to classify my test features which I have extracted here. Using that as the input, I'm classifying my predicted labels here. So using that, I'll be able to quickly get my predicted labels for my trained classifier, which I have been able to completely generate from my test features, right? And using simple confusion matrix function, we can easily visualize the output for each label, how the prediction has been done. So if I visualize that, you'll be able to see for almost most of your labels, you are getting output more than 50% accuracy. And we have only two labels, if I remember correctly. One is for digit 0. We have 25% accurate, true prediction. And for digit 6 or 7, if I remember, it is for digit 7. And if I checked why that is happening, because due to the feature of letter 7, the symbol 7, so it is similar to the digit 1, where we also have a short sharp edge on the top edge, right? And even we have a similar feature in terms of digit 2 as well, and even in that for digit 3 as well. And again in the digit 7, sorry, even in the digit 6 we have that sharp edge. And along with that, for digit 7 we have the actual true prediction as it is. So other than that, we are getting more than 50% prediction for remaining all the remaining labels. So that is what I was able to achieve using this. But there is not only limited to this. When it comes to feature extraction technique like this, so this HOG feature extraction feature which I'm able to use here, it is not a part of image processing toolbox. It is a part of one more function, one more toolbox called as computer vision toolbox. Whenever you are doing feature extraction, so you are coming out of image processing and you are utilizing the computer vision toolbox. So let me quickly open the documentation for the computer vision toolbox. And let me quickly show you what are the different other features which are available to you very quickly. So if I go to the alphabetically, if I go to letter C, yeah. So we have this computer vision toolbox available here. So in which we have multiple feature extraction and detection techniques that are available for you. So if you are focusing on only the feature extraction, so we can go for this extract features section, and you'll be able to see we have multiple feature extraction. If you are focusing on only point descriptors, we have the actual standard extract features function. If you are focusing on local binary pattern based features, we have LBP features. If you are focusing on histogram oriented gradient features, you can use that as well. Along with that, you have multiple other feature extraction techniques like serve features, orb features, and even brisk and fast features as well. And even one of the popular Harris features is also available for your corner point object detection and extraction. So you can use these features in a very simple fashion. And along with that, even if you're focusing on matching your extracted features or matching your detected features, you can use this inbuilt function, and you can match and verify for your original image whatever the features you had extracted, how it is how it is getting mapped out in a very simple fashion. So this is the toolbox which we are using here. This is basically these functions which we are using here are part of the computer vision toolbox. So this is the extract hog features which we utilized in this particular example is a part of computer vision toolbox. So I utilized this to extract the data feature points, and utilizing that I was able to easily come up with the implementation of machine learning algorithm, and we were able to come up with a classifier model for our digits for our digit data set, which is basically an image data set in a very simple fashion. Now we also have one more way, which is the deep learning way to do that as well. So I'll be talking about that in the upcoming session. So no need to worry about that. We have a dedicated session where we'll be discussing, where we have a continuation, where we'll be moving from the machine learning aspects to the deep learning aspect as well. So on that particular day, we'll be totally focusing on the machine learning aspect in a very simple way, and we'll be discussing that. So we have come to almost the end of this particular session today. So we are almost 10 to 15 minutes overtime. So no need to worry about that. In the deep learning session, there will be no any overtime. We'll be finishing this session in within the time, because we have a very limited number of workflows to discuss, where we had here more number of workflows to discuss, so we had a little bit overflow. But keeping that in mind, we have come across almost the end of our session. Let me quickly show you my contact detail. So if you have any kind of questions at any point of time, so this is my email ID, as you can see on the screen, rakshit.bs@corel.com. So you can contact me at any point of time whenever you have any kind of queries, not only with respect to image processing or machine learning, anything with respect to Matlab. If you have any kind of queries, you can feel free to write to me. I'll be happy to take your queries, and I'll be happy to address your queries at any point of time.
Actually, the yellow faculty.
Thank you, sir.
Thank you, Rakshit sir. It was a wonderful session. I hope all participants enjoyed the MATLAB and hope their queries are clear. Any questions is there, you can ask. By that time, I'll share the feedback link in the chat box.
Sir, I have
Hello.
sir.
Excuse me, sir. Hello, excuse me, sir.
Yes.
Sir, can I apply HOG features method for lung city images, sir?
Yes, you can do. HOG feature is basically a kind of edge detection technique only, because if you were able to see in the PPT, right, edge detection is using basically the gradient technique. It is using the differentiation, and based on that gradient, it will go and find out the direction in which it is able to find out the edge. Similarly, even histogram of gradients is similar to that. If you want to understand more about HOG features, I can share you the detailed documentation. But basically, in a net, if you want to understand what you mean by histogram of gradient technique, it is basically similar to the edge detection technique, but it will also keep in mind the direction in which also it is being identified. Even that direction also is one of the important feature that will be taken into consideration. So if that particular thing is critical for you, while you are detecting the features in your image, even direction is also an important feature, then HOG features will be pretty much really helpful for you. You should be able to get good set of outputs from that. If not, then as I told you, let me show you in the documentation as well. There are multiple other features that are available. HOG is one of the feature extraction technique. So you can go through the documentation on the computer vision toolbox, and you can utilize multiple other feature extraction techniques, and you can utilize those features as well, and you can try out which particular feature will give you the good set of results. In some of the cases for medical images, using statistical techniques will also help you much more better output. So as a first thumb rule, rather than using the standard feature extraction techniques, I recommend you to extract the statistical features. Like for a given image, you can extract statistical evaluations for that. I can share you the documentation for that as well. You can try to implement that particular technique. Even after that, if you still feel the accuracy is not sufficient enough as per the ballpark expectation level you had, then you can go further with these specific feature extraction techniques. You can go through the documentation and you can try to identify what are the key workflow in which the feature extraction happens, because all these feature extraction are not black box. As you were able to see, you can open the documentation and you can easily try to identify what is basically happening with respect to that function you are utilizing. So you can go through that documentation and you can try to identify whether that particular workflow is matching with the requirement for your particular data set. If yes, then you can easily use that and you can try to utilize. But if you want to just blindly try out, then that is also one more good way to do that. Sometimes I will do that as well. I will blindly try out multiple functions and I will find out whichever the technique which is suitable for me. So in that case also, you can try out multiple features. It will not take too much amount of time. It will be able to quickly, if you have a GPU especially, it will be able to give you results in a much more quicker fashion, and you'll be able to try out and you will be able to find out which particular feature extraction is giving you the best set of results.
Thank you, sir.
I hope I have answered your question, sir.
Yes, sir. Yes, sir. Thank you, sir. Thank you, sir.
Excuse me, sir.
Yes.
Thank you so much for such informative session. Today, you implemented the same on a Matlab, right? If you don't
Yeah.
mind, will you please share some uh, implementation part on Keras library? Nowadays, we all are working on Python too. So we really want that
Yeah.
there should be some kind of a classification using like a feature extraction of this. Most of the time we prefer for a ResNet 50, ResNet 101 v2 or dense,
Yeah.
right?
Thank you for coming that question, ma'am. I'm basically the application engineer from Matlab tool. So that
Okay,
is
okay.
why I'm showing you the workflow that is involved in how we can implement this using Matlab as a tool. But no need to worry, there will be other people who will be giving you the workflow in terms of Python as well. I'm
Yeah,
sure
sure.
they'll be giving you the workflow in a very short time. But in my case, on September 19, session 3, at the same time where we started machine learning and the continuation of image processing today, at that particular session, I'll be going through the workflow that is involved for your deep learning application. Using the
Okay.
same machine learning, using the same MATLAB, we'll be going through how we can utilize, like you are talking about ResNet 50 or AlexNet. We can use neural networks automatically, and also we can visualize the features, whatever the network is able to learn. We'll be discussing about that in September 19. Sorry, it's not September 19. I'm really sorry.
September,
Why
yeah,
I don't know.
January
On Jan
September.
19th. Yeah, thank you for correcting me that. So on Jan 19th session, so we'll be coming across that as well. But again, there we'll be talking about how we can do that in MATLAB only. But still, if you are
No
still
issue, sir. That would be wonderful, even because somehow I just want to gain some knowledge on the same. So that would
yes.
be better if you will continue the same on MATLAB. Just I wanted to see some implementation on the feature extraction as
I
well as
think
some
there are few
SVM
other
classifiers
there
too.
will be few other resource person who will be able to help you for that as well. Since I'm a application engineer from Matlab,
Yeah,
so
sure.
I'm
Got it.
majorly using Matlab as the major tool for implementing my applications. So that is why I'm able to show you these kind of extended implementations in Matlab. But no need to worry, there will be other sessions which I think as per the schedule you can see, where they'll be they'll be explaining you or explaining the same set of implementation in various other platforms as well. I think you'll be able to go through that. But along with that, in Jan 19 session, I'll be also talking about interoperability. Like if you're using other platforms, and if you
Yeah.
want to import that libraries into the Matlab, or if you want to export your Matlab library into the different platform, we have interoperability function that is available. So I'll be talking about that as well. I think that will be helpful for you in that session as well.
Yes, sir, sure. Thank you so much.
Yeah, thank you very much.
Sir, can
I
you,
have
sir,
one
can you
question,
share
sir.
the resources, sir? Today the script what
Sure,
and all.
sure. Yeah, I
Yeah.
request the coordinator of this event to provide me the feedback form details so that I can send through email whatever the examples I have shown you here.
Yes,
I'll be
sir.
sharing even including the data files, including I'll be sharing separately to all the users so that you
Yes,
can
sir.
go through those files and you can, if you have any questions, you can feel free to contact me at a later point as well.
Thank you,
Sure,
sir.
sir. We'll
Thank
do
you, sir.
that.
Thank you, sir. Thank you.
Yeah.
Any other queries from participant side?
Sir, one basic question, sir.
Yeah, yep, ma'am.
Sir, actually, from the data set, I tried to load the document into the FPGA board, sir, in the BRAM, block
Okay.
RAMs. So at that
Okay.
time, the coefficient file is in the normal file form, in the sense it is easy for me to load it everything. But when
Okay.
it is in the floating point with the negative sign, at that time, whether I commit mistake in radix or not, I don't know. But the details are not loaded into the BRAM.
Okay.
Uh,
I am not sure specifically why, because I'm not using FPGA extensively to talk. This is a quantization error you are talking about. I came to know about that.
yes,
What happens is I don't remember. I think either 18th or 19th. I don't know which date.
yes,
One
sir.
of the colleague from my organization itself, who is
Yes, sir.
called as Dr. Prakash G. He will be a part of the session where he'll be talking about implementing these kind of applications in FPGA board. I recommend you to be a part of the session, ma'am. Whatever the question you have, please feel free to put the same question to that particular coordinator. He will be helping you to. He will be able to help you because he is the person who
Yes,
works
sir. Yes, sir.
specifically
Yes,
for
sir. I
Xilinx
know.
school.
Sir, G Prakash, Coral.
Yeah, yeah,
I know him, sir.
yeah. He will be able to answer that question much more better compared to me, ma'am.
Okay, sir. Okay.
Yeah, he will
Thank.
be. I don't remember either tomorrow or 19th. I think session 2. He will be part of that particular session. I
Yes, sir.
recommend you to be a part of that event. He will be able to help you with that, ma'am.
Yes, sir. Thank you. Thank you.
Yeah.
Sir, I have one question, sir. Sir, if
Okay.
at all we are doing this MATLAB application in Python, Python is a
Uh-huh.
free software, but
Yeah.
in Python also MATLAB you can import. Is it
Yeah, we
free
can
or
export our MATLAB libraries into the Python environment, or if required, we can import the Python libraries into the MATLAB environment as well. That interoperability is supported.
is it free, sir? Because MATLAB is not free.
Yes, MATLAB is not free. MATLAB is not free, but if you have MATLAB available with you, then that interoperability is supported.
Okay, sir. Okay. Thank you, sir. Thank you.
Yeah.
Okay, thank you all the participants. Thank you, Mr. Rakshit PS. It was a wonderful and informative session, sir.
Sure.
Thank you so much.
I hope no other queries. And I'll share the attendance link even in the WhatsApp group. Whoever can't able to fill it from here, they can fill from there. Okay, thank you, sir.
Thank you very much, ma'am.
Okay.
So I hope all the participants had some value in this particular session. So if you have any kind of queries, please feel free to mail me through my email ID. So I'll be very happy to take up your question, and I'll be happy to address your queries. So thank you very much. We can call for this end of this session today. Thank you again. We'll meet back once again on 19th at session 3.
Thank you very much, sir. And thank you all the participants. Hope the session was very informative. Okay, then we'll meet in the next day with the different sessions. Thank you one and all. Now I'm going to end the session.
Thank you, ma'am.
Thank you.